So, good morning, ladies and gentlemen. I'm here both representing my company, MIM Italia, a small metal injection molding producer in north of Italy, and in my position of co-chairman of the EuroMIM group, the sectoral group in the EPMA, for members that are involved in metal injection molding. It's an honor to be here on occasion of the 25th anniversary of the European Powder Metallurgy Association, our home, to present this paper about the development of metal injection molding in our continent and the role of intellectual property rights, that is, patents. When Jonathan Rowe asked me whether I would accept to do this, I had immediately stated that I was ready to do it, but with a condition. I wanted to be just a sort of collector of information and stories from the people who really were active in the early days, a sort of spokesperson of a wide panel of industrial and academic people who really played their part in the game. That is the reason why in this first slide you see a long list of co-authors. And I would say that they are the authors and I'm just a speaker. I think this fits better the situation. And having said that, let us move to the presentation. Okay, I guess we should not spend too much time in explaining what metal injection molding is. You can see the process steps in the chart. It is a net shape, full density powder metallurgy process that takes the advantage of shape capability from plastic injection molding and a metallurgical advantage of using ultrafine metal powders plus high temperature sintering to achieve large series of usually small, few cubic centimeters, light, less than say 50 grams, but complex parts with good geometrical tolerances and competitive prices despite the high cost of raw materials. And MIM is not the newest technology in the PM family, but it's still growing very fast. It has grown even during the crisis we have or will have gone through, and attracts more and more applications as designers are becoming more and more aware and believe in the reliability of the technology and of MIM producers. I'm not giving you any status of industry here. For that, I invite you to join the EPMA community at our next Congress in Salzburg next September. Here, I will tell you the story of how it began and developed, concentrated on the early years, and that's last millennium, basically, and relevant companies. Okay, I can't start from the Garden of Eden, but it's well known that the origins of powder injection molding date back to the 20s, when the first applications, namely ceramic injection moldings like spark plug, insulators, well, where's the pointer? Here, yeah. For early cars appeared also in Europe. After all, ceramics are made of oxides, namely metal oxides, so why not thinking that they were molding oxidized metals? Okay, it's a joke, sorry. Actually, it took several decades before the availability of suitable powders and equipment allowed for the production of MIM parts. And Raymond Weech, one of the four co-founders of Palmatech, the California company that incidentally just celebrated last year 40 years since foundation in 1973, obtained a patent on solvent debinding that is at the root of the whole history of MIM in 1980. In 1981, the four partners divided their roads. Peter Roth, who was a Swiss, went back to Switzerland and founded Mold-Inject, whereas Suger, who was Swiss as well, stayed and led Palmatech, which founded Whitec in San Diego, another company that also owned the rights on the patent, and Millet founded Millet Sites, also in USA, to produce weapon parts. What I myself have discovered during this digging of information to prepare this talk is that the beginning of a MIM in Europe can be dated back to the 70s as well. According to what Hartmut Walscher of Harburg reported in 1976, Dentarum, a major German orthodontic and implantology producer located in Inspringen, close to Pforzheim, bought an Harburg machine to start working on MIM with in-house feedstock. Harburg actually sold its first pin press to Fellmühle in 1963, so in 1976 a MIM application was not totally new for the Losburg company. Dentarum has been successfully producing orthodontic brackets and other parts by MIM since the 70s or maybe early 80s. The fact that orthodontics is one of the main markets for MIM in the USA in the first place is well known and again evident here. And also according to Hartmut, MTU München, a leading producer of aero engines, bought a press in 1977 and started working on MIM as well. So at least these two companies, Dentarum and MTU, plus Mold-Inject, have been producing metal injection molded parts throughout the 80s, well before the technology developed as a widespread process in Europe. And during this decade, the 80s, other activities started in Germany. An early player was the Degussa, now Evonik. According to a 1990 paper by the under F.P.'s III that was published on Metal Powder Report, the Degussa, based in Essen, started working on MIM back in 1981. They already were injection molding thread guides out of various ceramic materials. They also cooperated with Bidurit in a research project for hard metal spin, together with Krebsöge. I will come to them in a minute. And they started producing metal parts, both low alloy and stainless steel, and also tungsten alloys, magnetic steels, and nickel-based alloys and tungsten carbide parts. Now, in 1990, when I was a junior researcher in my previous company, Centro Sviluppo Materiali, a research center on materials in Italy, I started to work on ceramic and metal injection molding, and I stayed 4 months with a group of Professor Bevis and Dr. Ian Pinwell, who later worked in the MIM business in Singapore, in the Brunel University in Uxbridge, here in London, where they had all facilities for powder injection molding. And after this initial study, I was asked to write a report that I completed in 91, along with some initial practical results. And here you can see what I reported in my analysis of a state-of-the-art of MIM about the Degussa. Unfortunately, it's a black and white photocopy, no color scanners those days, not even color copies. But as you can see, they had a detailed brochure on MIM and hard metal injection molding of Bidurit material, 1990. So Degussa was a chemical company devoted to selling raw materials, so probably because by the early 90s, the sales were not as expected. Although they were in a range of $1–2 million, they decided to sell their plant. According to Leo Prakash, who at the time was working for Leuco Lederman, a hard metal producer, his company had given him a green light to start the pin production. So he bought an arbor press and started producing several hard metal parts, including golf shoe spikes. Football shoe spikes were too dangerous for the players, he says. He also made a bid for the Degussa plant, but it was eventually bought by another materials company, Robert Zapp in Düsseldorf. And Zapp probably had a hard time in converting its expertise into production of parts, and after some years they sold the plant again to a subsidiary of Deloro Stellite in Koblenz, probably in 1999. And Deloro continued producing up to 2005, then the production was discontinued by the US headquarters, and the plant was sold to various companies, ending its lifeline. Georg Schlieper, consultant and now owner of Gamatec, supplier of equipment for part characterization, has been working for long years in one of the early MIM companies, Sintermetallwerk Krebsöge, that later became GKN Krebsöge. As he recalls, they started in 1987 virtually from scratch, apart from sintering knowledge, without any experience on binders and plastic technology, trying to mix powders with polyethylene polymer and waxes, polypropylene, stearic acid, and with a purely thermal debinding strategy. They also bought mixing equipment and an arbor press. And they had a lot of troubles in producing the first parts for photocopiers that are shown here in the right part of the picture, together with parts from the Dentarum in Schunk. And the picture dates about 1990, so this is a collection of early parts from the early European players. And in the early 90s, the breakthrough was given by the use of BASF feedstock. We'll talk about that later, of course. That dramatically improved the quality. And they installed the debinding furnace in open air outside the building with an exaggerated afterburner to get rid of acid vapors for extreme safety. But automotive applications became a reality, like the gearbox part for Volkswagen Golf demonstrated. And since then, the production has been continuously improving. Talking about Schunk, this German company lately owned 2 different sites that have been quite recently unified. One of these is in Gießen, where the activity started earlier under the lead of Dr. Henry Kort, more or less at the same time as Krebsöge, thus at the end of the 80s, with production of the well-known special tiny gear for Brown's electric toothbrush that were produced by the millions, the first real very high-volume part to be produced in Europe with metal injection molding. The other present company site, Thale, started working on MIM later in 1993 as Metallica, so in complete independent manner. And then the 2 businesses were brought together under the Schunk Group in 1997, so that until very recently they somewhat shared the production, roughly small parts in Gießen and larger parts in Thale, that's what I heard, and built up one of the strongest MIM group overall. I have heard that now all production is in Thale. And by the end of this decade, the 80s, not only we had already some MIM producers in Europe, but also raw material and equipment suppliers had started to acknowledge MIM as a growing market for the products and started developing explicitly for this application. And this led to great improvements also for MIM outside Europe. We already mentioned Harburg as a supplier of presses for the early ceramic and metal injection molding. They just celebrated 50 years of pin sales and 1,000 injection molding presses sold for the pin market. It is true that this company really has worked as a hub to stimulate initiation of MIM production. Before founding MIM Italia, we also went to them to clarify some issues, solve problems, and also, for instance, for feedstock development. Everyone knows the guys in the Harburg lab, and metal injection molding probably induces an automatic association to Harburg machines. But also, the Austrian supplier Battenfeld was already active in the field in the 80s. Here you can see a summary of Battenfeld machines, with an early one dated 1984, probably sold to Advanced Forming Technology in the USA for use in its MIM plant. And the Austrian company then continued delivering to the MIM community, of course, improving the technology up to the latest electrical units and the special macromolding devices. And as you can read, their machines, and probably you can read, I don't know, are widely used in the world. It's probably too small, but believe me. But before you put presses to work and deliver moldings, you need something to feed them. Here, Europe gave its contribution as well. So I have disturbed the retirement of Robert Bob Howells, who was director of the powder group at Osprey Metals, later Sandvik Osprey, since 1986. I think many of the people in this room met him, and anyway, you can see him in this picture at the Sandvik Osprey booth in Valencia, 2003, together with Roger Dunstan, manager of a powder group, and also involved in the development of the MIM business in Osprey. And Bob explained me that Osprey was looking for new powder-consuming processes and identified the MIM in the late 80s, but they had to develop the technology to achieve a good yield in the fines regions, these below 10 micron, because in the late 80s, early 90s, the most used powders were either blends of carbonyl nickel and or iron and high-pressure water-atomized powders from Pacific Metals, now Epson Atmix, or sieved fractions of fines from gas-atomized powders like the ones produced by Anvil in Sweden, now part of Carpenter. When Sandvik bought Osprey, they financed the pilot plant, and the research eventually gave Osprey the ability to supply powders with the right properties and with sufficient rate to satisfy the growing needs of European and the world MIM industry. But the event that actually created a discontinuity in the development of the MIM industry in Europe was the involvement of BASF. This huge chemical group really introduced not only just a technical novelty, but somewhat ended the age of patents and technology transfer strategies, introducing MIM to newcomers, just like a variant of plastic injection molding. And according to Martin Blömacher, who has been in the front row from the beginning, the interest of BASF for metal injection molding came as a natural attempt to create further market for the carbon and ion powders BASF already produced. And it's common in BASF that some products or even some waste of some business unit become the raw material for another unit in a sort of internal networking that increases efficiency. They call it Verbund. Thus in 87, 88, the powder group started learning the fundamentals of MIM in order to better characterize the powders and help the customers of carbon and ion, like for instance Parmatech in California. And they built up a considerable knowledge. And at the same time, they regularly met with another group of BASF, the Basic Research Lab, that was working on ceramic powders. In 1989, the two groups were having regular meetings, and the idea of developing a feedstock came out by coincidence. And another coincidence that happened when the two groups accidentally realized the potential hidden in the degradation of polyoxymethylene by acid at moderate temperature, the basis for the patent that was granted to BASF in 1992. It is ironical that a patent ended the age of patents. Of course, this is a bit pushing the concept to the limit, I admit, but actually before BASF, to start a MIM business meant either a long internal research project or an unusually expensive license agreement with subsequent hard work to make the technology fit for the parts you wanted to produce. With the BASF concept, the companies did not need to do that anymore. They just bought the feedstock and started playing with it, and the fuss about the rest of the process was not as huge as before. A real clever move that changed the height of the potential barrier for the initiation of new MIM companies and created the main difference between the European and the American way of managing MIM startups. And I remember my first contact with the BASF feedstock at the 91 Hagen conference in Germany. Yes, it was a German language event, but at that time my German wasn't enough to fully understand the proceedings. Here you can see the book and the start of the paper. And the presentation was given by Weinand and Blömacher. And as Martin recalls, was divided into the technical part given by Weinand and the managerial part given by Martin, that was concentrating in demonstration of the financial viability of a new debinding strategy compared to this typical thermal debinding. Oops. The development involved also Arburg, that tested the feedstock, that later was named Catamalt. But for instance, Arburg also started the same year the cooperation with Hertz to develop a different binding system. But in the early 90s, many companies were still continuing to start their activity with the old approach, get some technology from across the Atlantic or make it on your own. And Bob Howells gave me some info on a couple of British companies that were active in the early 90s and were in my radar at the time. So Royal Ordnance was a state-owned supplier of munitions to the British Army, specialized in tungsten-based penetrators and other applications based on cemented carbides. So they had presence in Sinter and became interested in MIM in the late 80s and started molding stainless steel and carbide parts, although their activity was not very big. Here is their brochure taken again from my old report. The Wolverhampton Plant was discontinued in 95-96, and a couple of managers started metal injection molding in UK in 96 within the PI casting group, buying out the plant. This new company was active until the end of 2013. Another British actor was Manganese Bronze, Advanced Precision Components, but they were probably active only in the early 90s. As I said, not all companies started with a new BSF approach. One outstanding example is Parmaco. Georg Breitenmoser was dealing with welding, but in 1987 he decided to leave Switzerland to get an MBA in California at the cradle of MIM. While being there, a friend took him to visit Parmatech, where they met with Karl Züger. Züger was Swiss from the same area as Georg. Georg was not looking for MIM, he just thought it was an interesting visit, and why not, yeah. After a short tour of a company in the morning, Parmatech was not very big at those days. Karl Züger took them for lunch at a restaurant in a nearby golf club, and there, in view of the Greens, he offered the chance to establish the MIM business in Switzerland by getting a Parmatech license. And Georg was not ready for that, but kept that in mind, and it was a sort of long-term project. And after returning to Switzerland and starting a different company, eventually found that some time after, the financial situation was then sufficient for the Parmatech offer, and he bought a license in 92, starting out Parmaco out of the Weech technology. And you can see here early pictures of Parmaco during the installation and of the early process. And actually, the big expectations did not translate into reality as quick as expected. The technology was okay-ish, but needed a whole lot of development to make it efficient and reliable, and the market was not developing fast enough. So, in 98, Georg had to come to an agreement with Carpenter that had bought Parmatech in the meantime, so they acquired Parmaco. That gave the company some financial stability, and things went gradually better until in 2001, Georg bought back Parmaco from Carpenter, and since then the growth has continued with good pace. Let's move to Spain, where Ecrumesa, an investment casting-based company based in Santander, started to analyze the MIM opportunity for smaller parts in 1990. The advantage was the sharing of services and labs with investment casting and, of course, the customer portfolio. Manuel Caballero told me that they also began looking for technology in the USA. They actually got a license in 91. But in their case, the BSF offer came in early enough to convince them to switch, and in 92 they decided to be partners of BSF and Kramer for furnaces. So, in 93 they installed the first Kramer MIM Master continuous furnace, a small unit with a catalytic debinding process integrated in the line. And here you can see some pictures of the installation given by Manuel himself and by Ingo Kramer. You can see him there, the owner of Kramer and past president of EPMA. After some work, in 94, they could produce the parts for firearms, locks, automotive, and general and mechanical engineering. And in 97, they separated the MIM business as MIM Acrisa and added the new larger MIM Master continuous line. And by 2000, the number of parts developed rocketed already to 600, and the figure has now reached 1,700, and the capacity has been increased to more than 200 tons of feedstock per year, a really impressive example of a large MIM company. So the BASF feedstock boosted MIM development in Europe, and the mid-90s actually account for the huge growth in Europe. If we stick to the chronological order, we have to come down to my country, Italy. And while we were developing some knowledge in Centro Sviluppo Materiali, some companies started on their own and were the first in Italy to apply MIM. We all probably know that orthodontics is one of the markets that BIM entered in the early years in the USA, and Leone, an established Italian orthodontics company, recognized the efforts of the American competitors and started looking for alternatives for their processes that at that moment included all the investment casting, machining, and assembling cold drawn parts. And in 92, they approached Harburg as they had their presses for plastics, and in 93, they got in contact through them with BASF. They chose to go with a new system, and in early 94, they made a test model to do some tests that led to a start in production with a plant based on BASF and Italian vacuum furnaces at the end of 94, beginning 95. They also indirectly stimulated another company, Microphone Bresciana, that heard about their new technology and decided to put up a MIM line, also based on BASF. Beside their investment casting established production in 95. That same year, even earlier, also Metrocast Italiana, another investment casting company very close to Microphone. They both serve the weapons production district that is the main industrial sector of Valtrompia, a valley stretching north of Brescia. Decided to invest in MIM, and so 95 saw all of a sudden 3 MIM companies in Italy. Only in the 00s there was some real increase with several companies, including us, coming up to MIM. MIM Italia 2002, Matrix 2003, CS or PM Technology 2003, MIMS 2005, and Tamao. And you must also add another captive MIM company, SIA Orthodontics. That is quite a list, so an Italian customer now has a large spectrum of choice of producers. And not all of them use the BASF feedstock, and also not all of them have investment casting. But another country had a big development in MIM during those years, France. We have to go back to actually the first MIM company in France that was Impact Technologies, established in 92. This company was part of a big Valurec group, such as the Swedish powder producer Envel, already mentioned. They owned a license for the so-called quickset process. This is a sort of dead branch in evolution in MIM technology, as it was dealing with a water-based binder, a sort of water glue that would be molded in a wet state, frozen in cold mold, and then dried off the shelf to leave the debound part. Similar concept has been pushed forward later by Honeywell and Latitude, the powder flow feedstock, but never made a real breakthrough. And just imagine the difficulty with frost on the molds and maintain the correct water content in the feedstock or to recycle it. So Impact have been using other binders for real production, but eventually, after having produced many parts and even increased their capacity, they stopped production in 98. Apparently, the plant was sold to a Belgian company. But 2 big consumer markets were trying at the same time to find a reliable solution to get the MIM process in their products. And as Jean-Claude Bier explained, a group of watchmakers of France-Comté region, namely Bourdet, HGT Petitjean, Cheval Frère, and Cordor, had already tested MIM after having seen the technology since 92 in the United States and Japan and having bought parts from Impact. The results from the suppliers were rather disappointing, but they had understood that there could be an improvement provided they would make the parts themselves instead of buying. In 95, they decided to join efforts and started Alliance in Besançon, one of Europe's bigger companies nowadays using the BASF feedstock. You can see a lot of pictures of the installation and of the present situation in Besançon. Actually, there was also another group of companies dealing with spectacles that could join this initiative, but in the end chose to go on their own to found Hoptech, part of a Comotech group now for SIM. Also in 95 and rather close to Alliance. They actually later produced also watch parts, so they were real competitors to Alliance, and this company disappeared in 2009. Talking about watches, we cannot forget ETA, a Swiss company owned by Swatch that began producing in late 94, beginning 95, and quickly became one of the biggest MIM factories with quite a number of injection molding machines. The Swatch Irony and several other models have benefited from the introduction of the MIM process, and also non-watch parts have been produced in this Swiss company. On the spectacle side, OBE, a German supplier of parts for the spectacle industry, started using MIM in '96, and since then it became a general MIM producer, and that is also for non-spectacle parts. In Germany, many companies were established in the 90s, BOVA, CM Pulverspritzguss, Hoch, Sachsen, and later many others like Mebus MIM Technik, Stenzel MIM Technik, MIM Technik, not really a big effort in names there, right? Reiner, Berner, Förster, etc. Germany became quickly the main country in Europe, at least for a number of companies. The list is very long, and the density of companies in Germany and the surrounding countries, Switzerland, Austria, the Netherlands, led, for instance, to the birth of the MIM Expertenkreis. Let me talk briefly about the Netherlands now. I would say that the first company to use MIM in Holland was ITB. In '96, they acquired a MIM business from Rheinmetall AG in Germany and started production with BASF and other systems. They have become very strong, especially in the medical, with sound titanium MIM production. And another Dutch company who dealt with powder injection molding, although more on the ceramic side, was Philips Lighting. And nevertheless, in 2010, they gave their plant to the Energy Research Center of the Netherlands that is now offering MIM and SIM. And last but not least, during 2002, Advanced Forming Technology, originally from Colorado and now grouped by the new ARC owner under the name ArcMIM, together with Flomet and Injectamats, two historical American companies, launched a European subsidiary in Hungary, in Redzag, north of Budapest. This was a huge installation and increased the MIM capacity by quite a lot. I have not mentioned all of the companies, it's a pity, but there was no time to do it, so please forgive any name left out. Let us give some example of suppliers also. AC Stark for powders in Germany, for feedstock producers, Höchst, Clariant, Meta, Schienen Schwarz, Polymer Chemina, Polymim, Bayer, Ambe, and others. And all of them have contributed to the development of the industry by feeding us. Some have made it to today, others have disappeared. Well, I mentioned only one furnace maker, but we should include several others like Gero, Elino, Pfeiffer, PVA, TAV, who have built good furnaces for the industry in Europe, both for sintering and debinding, also for the BASF debinding. About the debinding, we must mention all the solvent inspection solutions that we can find nowadays, like Lermi and Gisoma, for instance. And we should not forget also the suppliers of furnace furniture or insulation. There is one field I've not talked about yet, research. I will not go through all the group in Europe. The list would be impossible to even just read in a few minutes, if there are any left for the presentation. I will focus on the networking generated in Europe to foster and endorse research, and that means talking about the MIMNet in the first place. Georg Schlieper, who coordinated the project, explained that Bernard Williams, at the time executive director of EPMA, wanted to gather companies, engineers and researchers involved in MIM to develop standards for the technology and to raise some funding from the European Union for that. And the MIMNet project, a thematic network on European MIM standards, was started in '97. The consortium comprised many producers, suppliers, and research institutions. And in 2000, the outputs at the end of the project were a draft standard which was submitted to CEN and the first EPMA brochure on the MIM technology. But the most important goal obtained was the successful networking of all the partners involved. Here you can see a picture taken at the first MIMNet and RADNet meeting in '97. Unfortunately, due to the old picture and the time passed, some of the people are just identified by a question mark, but some of them are recognizable and some are very active today. During the years, the EU funded several MIM projects, and many companies were able to increase their knowledge, develop and validate materials, make better products with financial support that, because of the average size of a MIM company, is always very welcome. After the end of MIMNet, it was hoped that a new European network could be funded, but it was not possible. So in 2001, EPMA gave birth to the EuroMIM sectoral group. The EuroMIM actually meets on the occasion of yearly EPMA conferences, plus some other occasions, and most of the work is made by the steering committee, but within the EPMA and some volunteer members on the specific issues like the development of the ISO standard that was recently issued, or the organization of the yearly surveys or specific promotion and so on. But there is also another big group with similar goals. And the German-speaking MIM community in '93 had already formed a structure, the MIM Expertenkreis. It means Club of Experts. The expert enterprise meets at the member companies as different subgroups dealing with the various technical and non-technical issues of metal injection molding, and it is efficient in networking the member companies and helping the development of a business for everyone. And the two groups, EuroMIM and expert enterprise, are not actually competing but work independently, even if some members are in both groups. So, we've come to the end of my presentation. Oh, too fast. I will not draw conclusions, but because of the time has gone and because the story has not finished. Metal injection molding in Europe is more mature than 25 years ago, but yet growing and finding new applications and developments year by year, month by month, day by day. So just make a wish that in 25 years from now, someone, not me, will stand in a similar event and tell the story of the next 25 years. I don't know, maybe we'll get it by streaming to our neural network in the brains directly, but somehow. I just hope to be there and watch and think back to the old days when we were struggling to make it work. And thank you for your kind attention.